This is my part 2 of the lecture 2.2. We are discussing the properties of the inverse. Properties of an inverse matrix. One property I already discussed in the last lecture. That is, say A inverse is equal to A inverse A is equal to I. The second property is we have two matrices A and B are invertible. Invertible mean that we say when they are invertible, it means their inverse exists, that we can find the inverse. And as I told you that not for every matrix the inverse exists. We have discussed this value must be equal to, not equal to 0, invertible. So as I told you, we have matrix A. So matrix A is A, B, C, and D. So we say the condition for this to find A inverse is that AD minus BC is not equal to 0. When this is equal to 0, the inverse does not exist, so this must not be equal to 0. So they are invertible, their inverse exists. We say AB, we take the product, and we take their inverse is equal to B inverse, A inverse. So that's the property for the inverse. Then we are going to discuss the power of a matrix. Power of matrix. Very important set of properties of the matrix. We have first property, A to power 0 is identity matrix. Number 2, we're having A to power 3. I'm taking example. This is A into A into A. Number 3, we take A inverse of 3. This is equal to A inverse multiplied by A inverse multiplied by A inverse. We say this we can write also. Then A to power 3 power minus 1. We can write the power of A, and then we can just take the inverse of that one. We get the same result. So we're having a property here, number 4. We're having two matrices, A to power R into A to power S. As the power rule, same apply here. We're having A to power R plus S. Number 5, we're having A to power R to power S. This is equal to A to power R multiplied by the power S. So we're having the same property that holds for this one also. So number 6 is we're having A inverse. We take its inverse again, as in transpose. We get the matrix A. A inverse of inverse is matrix A. So we are having here number 7. We are having the same property as we're mentioning there, number 3. So that is the same one, similar to that one. So here we can have A power n power minus 1, inverse of this one, the same as A inverse power n. Very important property is 8. K times A inverse is equal to 1 upon K. K inverse is 1 upon K. K is a scalar. A inverse, we say K is scalar. K is scalar. We take the inverse of this one K inverse, that become 1 upon K, and we are having here this result. I just want to show you with the help of the example these properties which I have just mentioned it. Our example is we use the power rule to solve this one. Just clean this part of this one. Here we take an example, and I just show you with the help of example. We're having, let A be a matrix. A matrix A be an invertible matrix. As I told you, the invertible mean its inverse exists. We say A is an invertible matrix, and suppose that inverse of 7A is minus 2 7, 1, minus 3. The question is find matrix A. We're given here the inverse of matrix 7A and we want to find matrix A. So we are using the properties here to solve this one, solution of this. So one thing you must be very clear, we are saying here inverse of 7A. It means 7A inverse is equal 7A inverse is equal to matrix minus 2, 7, 1 and minus 3. And from this equation we want to find A. So the way is that we just take inverse of both the sides, as being inverse of inverse is A. So I take here inverse of both the sides. I get here 7A inverse whole inverse is equal to minus 2, 7, 1, minus 3. We take inverse of this one. Here use the property number 8 that we having here the property that number 8 also. We having inverse of 7, the inverse of A inverse, property 6. We having 7 inverse into the left hand side is A inverse whole inverse. So this is equal to, here we take the inverse, we get 1 over minus 2 multiplied by minus 3 is 6 and 1 multiplied by 7 is minus 7. Interchange is 2, we get minus 3 minus 2, then multiply here by, multiply here by 1, get minus 7 minus 1. So on the right hand side we get here, this 7 to the power minus 1 is 1 upon 7. A inverse A is equal to A. And you get here 1 upon 7 minus 1 is minus. And this we get here minus 3, minus 7, minus 1 and minus 2. So we multiply here by minus and multiply by 7. I can just write my result. Result A is equal to 7 times 1 multiplied by minus 1. That become here 3, 7, 1 and 2. So this is my answer. This is not the unique way of doing that one. You can use this property other ways also and you can get the same result at the end. You can just take the, I have taken this one, you can take only the inverse of this one, then multiply by 7 and then you can just solve this one first. For example, I can just tell you that the second way of doing that one, and then you can take the inverse of that and solve it. As I told, it's not the unique way of doing that one. You can write here the left hand side. We get here 1 upon 7, and then we're having A inverse is equal to, the equation is here minus 2, 7, and 1 minus 3. Then our A inverse is equal to multiply by 7, 7 into minus 2, 7, and 1 and minus 3. Multiply by 7, we get here minus 14, 49, 7 minus 21. And now we can find the inverse of both the sides, and then you can find the solution. Then you taking the inverse, we are having the property number 6, A inverse of A is equal to A, and we take inverse of this matrix, inverse of matrix minus 14, 49, 7 and minus 21. You get the same result. So you can complete it yourself. We take another example. We want to solve this matrix equation. We're having here the matrix that we have matrix A is a matrix and B a matrix. Matrix given to B is equal to 2, 0 and 4, 1. We want to compute or find the value of A, 3, a to the power minus 3. Then we're having this equation A squared minus 2A plus I. So we want to solve this one. So we start from the solution of this one. We find A squared, A into A. This is my A squared. Then you use it to find A cube. My A is 2, 0, 4, 1. And I'm having here 2041. So I multiply it. First row with the first column, we get 4 plus 0 is 4. First row with the second column, 0 plus 0 is 0. Second row with the first column is 8 plus 4 is 12. And second row with the second column is 0 plus 1 is 1. So I want to find a cube. So what's my a cube? My a cube is a square multiplied by a. So my a square I have calculated is 4, 0, 12, 1. And multiply it by a. My a is 2041. I take the first row, multiply the first column. We get here 8 plus 0 is 8. First row is second column is 0 plus 0 is 0. Second row with the first column is 24 plus 4 is 28. And second row with the last column is 0 plus 1 is 1. So this is my a cube. This is my first result. So my second result is I want to find a to the power minus 3. So I'm going to use the property a to the power minus 3 is equal to a to the power 3 inverse of this one. So I find the inverse of this matrix. So inverse of this matrix, I find here inverse of the matrix 8, 0, 28, 1. This is my a cube. So I get here 1 over 8 minus 0. Interchange these two, we get here 1 and 8. Multiply by minus 20, we get here minus 28. So my result is 1 over 8 into 1 minus 28, 0 and 8. So this is my inverse of the matrix. So next is my equation. I want to find here the value of a square. This is number 2. Number 3, I want to find the value of a square minus 2a plus I. So when we want to add, we have the property the matrix must be of the same size. So we can find here what is the size of matrix AI. This must be 2 by 2. So I write here I2 because I know this is 2 by 2. So this must be also 2 by 2. We can add two matrices and the size is the same. So I can write the value. I have the value of a square. This is my value of a square. This here is 4, 0, 12, and 1. Then I have minus 2 into a. My a is 2, 0, 4, and 1. Then I have the value of I2. My I2 is unit matrix of size 2 by 2. So now I can just simplify this one and I can add them. I'm having here 4, 0, 12, 1. I multiply minus. I get here minus 4, 0, minus 8, and minus 2, plus my I, my unit matrix of size 2 by 2. Now the addition is the component wise. So A11, A2, A11, B11, C11. We get here 4 minus 4 plus 1. Then A22, B22, C2, A12, B12, C12, A21, B21, C21, A22, B22, and then C22. So simplify this one. We get here 1, we get here 0, we get here 4, and we get here 0. This is my solution. There's a lot of variety of the questions in the matrix multiplication, and there are many other problems. You can just go to any book of the matrices and you can find the problem, and you can just use this one to solve to make more practice. So here we are going to develop the videos for you for the linear algebra, and you can like this one so that you can get the videos directly and subscribe the channel also. And also if you have any comments, you can put the comments there and we respond to your comments. So inshallah we'll continue with more material next time.